Hello world, welcome back to another Metared CTF 2022 second stage write-up video. In this video, we'll be walking through some of the reverse challenges from the CTF. Let's get into it. So we're going to start off with 1x02... ware. The cybersecurity office of our university found a problematic Python script being exchanged between students. Can you help them to find what it is? Okay, so they give you a nice game.py. Let's go ahead and open that. And it looks like base64 byte strings being initialized here. And then it looks like it's decoding them and evaluating whatever's inside of them. And if I had to guess, this probably is some kind of ransomware. So probably not the best idea to run it. However, we can just print out whatever this is. So we can just change this eval string. Instead of evaluating it, we can just have it print out like so, since it's decoding all that for us. And then now we can run it, see what that base64 string says. And it turns out to be more base64. Okay, so we can grab that and go to CyberChef. Paste it in. And now we have even more decrypted stuff. So here's the real ransomware, quote unquote, that's being executed. And there's another base64 string down here that we can decode. And that ends up being our flag. Ransomware failed. Let's paste that in. All right, moving on to Sneaky. This file is empty, I promise, nothing to hide. So they give us a nothing to hide file. If we go take a look at it. Let's see, Sneaky. It's a PDF file, but it appears to be blank. So what if we were to run strings on that file? Let's actually limit that length down so that it's not so much to look through. We'll do a max limit of 10. And right here, you can see a base64 string. We can copy that and paste that into CyberChef. And there's our flag. Reading is fun. So copy that, paste it, submit. Okay, let's move on to backwards. Someone encrypted our picture. We were able to get the binary used. Can you help us recover the information? Okay, so for this one, we're going to go to my Kali box to start with. And I had the file in here somewhere. Let's see, let's go to... there we go. So I don't know what that is. Let's remove whatever that is. But here I had the files. And if you notice, a.out is actually a 64-bit ELF file. And inc.inc is just going to be our encrypted flag. So let's go ahead and maximize this, and let's just open up a.out with Cutter. Let's go to main. Okay, so we have some readable hex values there. Let's see what they say. This key is very bad. Don't use this. And if we scroll down, we can see that there's an AES encrypt key, an AES CFB 128 encrypt. So it looks like our flag was encrypted with AES CFB 128, which we can easily decode in CyberChef. So let's maximize this. Let's open up the inc file. Where is that at? Here we go. Backwards, inc. Okay, let me close that. Remove that. Okay, so now we just need AES decrypt. And the key was... This key is very bad. So let's make that UTF-8. This key is very bad. And then I believe it was CFB, and then it should do 128 by default as one of the options, depending on our key and initialization vector lengths. And I'm guessing the IV is the same as the key, so this key is very bad. Oh, and the input is raw. Okay, there we go. We can see an IDAT header there. And if we scroll all the way down, we see IEND. So this is definitely a PNG file that's corrupted. So let's save that. And let's call it download.png, like so. I'm gonna open that up. Okay, and now we need to correct our corrupt PNG, which we can easily do by opening that in HXD, and then opening another PNG in HXD, a correct PNG anyways. And then let's go ahead and title this vertically so we can compare the two. All right, so it looks like our first line is the one that's corrupted here. So that's easy to fix. We'll just copy the hex values from the correct PNG and paste them into the, well, where those would be in the corrupt PNG. Save that. And now let's retry opening up our PNG file. And there's our flag, rev. So let's put that into the flag submission box. And submit. All right, let's move on to the final reverse challenge I solved, grades. Student grades. Is this encoded or something? And they give us an XLSM file, which is an Excel file with a macro on it. Let's close that. I'm going to use Kali to solve this once again. Let's close that. And then we can maximize this. Clear, ls, and then we need to go to grades. Now you'll see I have a solve.py script, but we'll look at that in a second. What we want to try using is ole VBA on the grades.xlsm file. And you're going to notice that it performs this XOR operation on the cells. So if we were to actually open up that XLSM file, which I have right here, you can see all the numbers that are in those cells. Now, don't open up Excel files with macros because it could execute them, but usually it's fine because they have this enable editing, which prevents stuff from being executed as well. So it's unlikely that something will execute on load, but just to be on the safe side, don't typically open these. But anyways, you can see these values in here, and all these are being XORed with this X value right here, which is right here. And then for whatever reason, it's doing I equals I plus 1 and X equals whatever, but this is outside this for loop. So it's actually going to XOR all the values with the X value first and then do this. So these two lines are pretty much irrelevant for what we want to do. We just need to XOR all the values from the Excel spreadsheet with the X value here. And that's very easy to do. I'll pull this over here and we'll run gedit on sol.py in the background here. Okay, so I used the OpenPyXL library to solve this, which will let you ingest Excel files and be able to pull the values and stuff from them. And here I define X, of course, which is just the X that you see up here. And then I define a decryption array that I don't need anymore, so I can delete that. And then I loop through the rows. And then for each cell in every row, I take the value of the cell and I XOR it with the X value. And then of course I print it all out on one line, and since it becomes an integer after that, I convert it to a character so that we can get the plain text. And that's all there is to that. So let's go ahead and run the solve script. And right here you see this could be the flag, but is not. Sad. And then you have CTF UA. Do you know this could be malicious? So grab that, paste it in, add the closing curly brace, and submit. Now I already solved this because I didn't know if that was the flag or not, because I didn't know what all this other jargon was. I thought that maybe the flag was further obfuscated or something. So I went ahead and tested it to make sure, but that is indeed your flag. I think that wraps it up for all the reverse engineering challenges I did. So if you enjoyed the video, drop a like and subscribe to the channel to show your support. Turn on post notifications to get regular injections of cyber content directly into your feed. Check out our Patreon, join our Discord, and follow us on Twitter. Links in the description box down below. And leave any feedback or questions in the comments section down below. This is Almond Milk. Thanks for watching. Goodbye, world.